Friends, let's see the application in continuation with previous projects like traffic signal and individual 7-segment display. Now, I'll continue with present time display program on multiple 7 segments. The concept behind dealing with this multiple 7 segment is very clear. Whenever you are working with this multiple digits, there is a common line setup here. All 7 segment digits data lines are common as A, B, C, D, F, G, H, and data lines there are common, and you need to manage the common pins. Maybe it is a common anode or common cathode, so you need to manage with programming. So that is the concept behind for this handling multiple 7 segments. So anyway, each segment have 8 data lines. So this is the common anode. I'm taking as 4 digits. I have the values already with common anode, so I'm taking common anode. If you are proceeding with common cathode, change the logic to 1. So there is a simple thing behind for this common anode and common cathode. So this common anode 4 digits. So this is the construction of common anode 7 segments, as data lines are common and individual common pins. So coming to the connection, so make sure your data lines are connected with 8 data lines. The segment A is connected with pin number 2 and segment B is connected with pin number 3, and so all this A, B, C, D, F, G, H connected from 2 to 9. So this is how the data lines are connected. And coming to these common pins, generally if it is an individual segment, we will go with anode and cathode, which means VCC or ground. But now here I am connecting with IO lines. Whereas in real hardware, you need to manage this common lines with the transistors as data lines connected with IO port. So this is the connection required if you are handling maybe 4 digit or 6 digit or 8 digit common anode or common cathode 7 segments. So this is a connection required between the common pins and data lines. So for this I am trying to display present time as my time is 1:30 now. So the program from Arduino I just developed already. I'll explain. Let's see the line by line code. And coming to the hardware connections, whatever I have, the segment A to H, which are connected from pin number 2 to pin number 9, and the common pins of your 4 digit 7 segment connected across pin number 10, pin number 11, 12, 13. And configuration is also required in the setup part, whereas pin mode, each pin is configured as output from A to H, the common 1 and common 2, common 3, common 4, which are configured as output. Now, so whenever you are expecting number on first digit, make sure one common pin is high, the other common pins are low, so that it allows to print one number on first digit. If you are making all common pins are high here, then it allows to print the same number on 4 digits. So make sure the other common pins are low, and the delays should be very less whenever you are providing number to the digit, so that it will maintain some time. So based on the response time of 7 segment, so displays or handled based on response time is also one of the important parameter while handling displays. So your 7 segment will hold some time even if you remove the supply, which means by deactivating your common pin with the logic. And if you need to come back by writing the same values in the loop, so that it allows to handle the same number again and again. So while giving the number to the first digit, make sure first common pin is high, the other 3 common pins are low, and provide your number. So I am giving 0 equivalent logics for the first digit. The delay, which is very small, I am giving here so that it will hold some time and switching from first segment to second segment with very less time delay, which is 200. So that the first digit, which will hold some time with this small time delay, and second common pin is activated here, and the equivalent of second digit number I'm assigning here, which is 1 dot. So even I just make sure the first second digit with the dot, and the third number I'm expecting 3 on the third digit, so that I'll make it third common pin is high and other 3 common pins are low, and the fourth digit, which is 0, again the equivalent value I'm displaying here now. So now compile this program and link up your hex file path with the hardware design. So this is your hex file path. Just copy the hex file path and run in the hardware design. So just double tap on controller and paste on program file. Now you can run the simulation. So still, which is allowing to display individual numbers. Now 01.30. Now I'm expecting this complete display with very less time, so I'll decrease the time here. Even the 200 is becoming too much for this, I'll proceed with only 50. And if you do any modification with the program, just compile once. The path is same, so no need to worry with the path, and stop the simulation and play it again. So this is how, which allows to display present time on the 7 segment. And if you keep it in while loop, so maybe because of loop which is taking more time, I'll keep this entire process in while. So this is how you can display the, still I'm expecting 4 digits at a time response, so I'll proceed with very less time delay from the program. So I'll proceed with 10. So just compile the program and run the simulation. So this is how you can display present time on 4 digit 7 segment by managing with less time delay and keeping it in loop. So these kind of applications you can do more with multiple 7 segments, like digital clock or multimeters or time date display programs or counter systems. There are many more applications in the coming videos by using this multiple 7 segments by using Arduino. Thanks for watching.